Assalamu alaikum. Welcome to Crack Mathematics. Lesson 6 today is about addition. So let's start the lesson. You know what? Let's start the lesson with the question, which is totally weird. So if I ask you, what is addition? So what your answer is? What do you think? The common answer I got all the time is like addition is like 5 plus 2 equals 7. So this is what addition like. This is the comment I got from most of the students. There are different definitions, but this is the most common that I receive from most of the students, or the first thought of the student. But this is not addition. This is a counting process. So this is a counting process. How is that? Because I just start with 5 and I count 2 units. I will reach 7. So that's exactly what's going on here. So which is part of the addition concept. So the counting process is part of the addition concept. So this, I call it a counting process. Or counting actions if you want. So it's so counting action, which is part of the addition concept, which we are going to see. So, and another question: if you ask a third or second grade student, so if you ask them, okay, can you operate those two numbers or this operation? Can you evaluate this operation, for example? So if you ask them, can you evaluate, for example, 12 plus 15, and trust me, he's gonna be happy to do it, because you can say, okay, this is easy, this is 25, this is 27, sorry. So, and if you ask him how you did it, he can say, okay, I add 2 with 5 and add 1 with 1, which means that there is a rule, because why he didn't add 2 with 1 and 5 with 1? So that means there's a rule that he follow here in order for him to, or her to, get the right answer. That means addition has a rule. So here addition has a rule. So this, let me put it here. That's mean addition has a rule. Now if you ask another question, okay, can you, for example, add the following? So if you give him this question, 4, we have x2 plus 5x plus 3 plus 5x2 plus 3x3 here plus 2x plus 1. Trust me, he's gonna step back and say, okay, oh no, this is college stuff. Now my question, what's the difference between this addition, so if I add those two, and this addition, what's the difference? The difference is the student is familiar with the component of the addition here. The student is not familiar with the component here. That's the only difference. Is it the rule that we apply here is the same as the rule we apply here? Yes, the rules are the same. There is no difference between the rule here, because this is one thing, which is addition, and this is addition. That means the rule that we apply here is the same as we apply here. But the problem here is the component, the student is familiar with the component here. The student is not familiar with the component here. This is why he stepped back and said, okay, no, I cannot do this. So my question now is, do we operate based on component, if we are familiar with the component, or based on rule, if the component satisfies the rule? So how we operate, or how we add. So this is the question I'm asking here. How we add here? We add based on what? On component or rule? So do I need to know the component to add, or I need to know the rule to add? This is the question. So what do I need to know the component to operate, or do I need to know if the component satisfy the rule of the operation? So this is my question, and the answer I got for this question is we need to know if the components satisfy the rule of the operation. So can you believe it? So most of the students answer positively for the second question, that we need to know if the components satisfy the rule of the operation. And this is true. So if the components satisfy the rule of the operation, then we can operate. So if component satisfy the rule of the operation, then we can operate. Yes, and this tells me that addition in fact is what? Addition is an operation with rules. Is an operation with rules. So this is what we got now for addition. So before I move on, what is operation, or how we can define operation? So in fact, operation is a process or a set of action that produce or generate results. So that's exactly what is operation. Operation is a process, or we can call it set of action that produce or generate results. Generate result. And as addition is an operation, with rules, sorry, here. So as addition is an operation with rules, and operation is a process, that means addition is a process. And this is the first statement for by definition for addition. So addition is a process. So this is the first thing we start with. Now let's start the lesson of addition. What we did till now is just an introduction to addition. In our daily life, either we combine or we mix quantities. Suppose I have this set of quantities and I want to create a single set of the first two, and I want to create a single set of the second two. So which action I should take here? Combine or mix? And which action I should take here? Combine or mix? So, and if I choose combine Y and choose mix Y, and the same thing for the second set of objects. So for the first two item, so I combine, and the second two item I mix. So we know combine and mix, they have the same meaning, get item together. So here why we choose combine, and here why we choose mix. For the first two set, so we choose combine because the item are similar. This is why we choose combine. So we choose combine when the item are similar. So those two are similar. And we choose mix here because the two items are not similar. Now if I take the action and combine those two quantity and I mix those two, in the combine process we got a new quantity similar to its original component. In the mixing process we got a new quantity not similar to any of its original component. Here I can get the total by counting, and the total is 18. So what about the unit? The unit here is similar to its original component. So we have 18 banana, and I will choose B for banana. If I count here I will get 17. But I cannot say 17 banana or 17 pepper. So I can use none of the original unit. So in that case I need to create a new unit. So I will say I have 17 item. And I will choose I for item. Now let's summarize what we got so far. With combine, the components are similar. And the unit of the component, or the unit of the result, is similar to the component. With mix, the components are not similar. And the unit of the result is not similar to any of the original component. It is not similar to any of the original component. with combine, the amount of each component increase. So if you remember, we combine 8 banana with 10 banana, and we got 18 banana. You see, this amount increased to 18 and this amount increased to 18. So this is the output or the result of combine. The amount is bigger than the amount of each component. With mix, the amount of each component stay the same. So if you remember, if we got 7 pepper and we will mix 7 pepper with 10 banana, the amount of each component is increased, so we still have 7 pepper and 10 banana. So the amount of each component stay the same. This means here we didn't get any increase of any of the component. So this is about mix, and this is about combine. So my question, so what is addition? Is it a combining process or is a mixing process? Addition is a combining process. So now let's write the definition of addition. Definition. So addition is a process of combining similar quantities called adding into a single similar quantity called sum using counting concept. So this is exactly what is addition. So let me write it down here. So addition is a process of combining similar quantities, and we call those similar quantities adding, so called adding into a single similar quantity called sum using counting process or counting concept. So this is exactly what is addition, and we use this symbol. So read plus to represent addition. So we have adding plus adding equals sum. So example. So I'm going to use the example we did. So we have 8 banana plus 10 banana. We got 18 banana. Now the most important question, so how we apply this definition. Let's see the first application of this definition with numbers, and you're going to learn now why we add the number like this way. Remember, every number is a mixture of distinct quantity. Every number is a mixture of distinct quantity. So for example, if I have 423, so I have the ones, the quantity of the ones, the quantity of the tens, the quantity of the hundred, so and so on. So every number you pick is a mixture of distinct quantity. Now if I want to add, for example, those two numbers, 200 for example, 53 plus 170, let me pick something simple, so 41 for example. I want to add those two numbers. So how can I apply the definition in order for me to get the total? Definitions state that addition is a process of combining similar quantities. So I need to combine only similar quantities. Besides that, I cannot do addition. So here I'm going to look for the similar quantities. You see here, this is the ones. This is the quantity of the ones. I cannot add the quantity of the ones to this one because they are near to each other. No, this is the 100. This is the quantity of the one. This is the quantity of the 100. So I cannot combine those two. So I will combine this with the ones. You see, similar quantities. So I will combine similar quantities. In other words, I will combine the corresponding place value if we want to use the terms place value. So I combine the corresponding place value. Why? Because they are similar quantities. So I will combine this with this, because this is the ones. I combine with the ones. I combine quantity of the tens with the quantity of the tens, and I combine the quantity of the 100 with the quantity of the 100. So this is exactly how we apply this definition in numbers. So I have 4, 9, and 3, and this will be my answer when I add those two numbers. And if I want to add shapes, for example, if I have 3 triangle plus 7 triangle, so what's going to be the total? So it's going to be 10 triangle. And if I have 4 square and I added to 3 triangle, what's going to be the total here? They're not similar. I can do nothing here. I just want to keep this as the same. You see, they're not similar. I cannot add them. I cannot get the total because they're not similar. It's the same thing. I cannot add the tens with the ones. They're not similar. If I have, for example, 5 apple or 5 banana and 2 pepper, I cannot get the total here. You see, I cannot get the total. I have 5b plus 2p. I cannot get nothing here. So because they are not similar, I will have the same thing. The same thing if I have, for example, 5 banana and 4, which is a known quantity. I don't know what's 4 for what. I just have 4. So here I cannot do nothing here. Even though if I have 4 plus 5 banana, it's not because 4 is near to 5 I will add those two. No, I have 5 of this quantity. So that means I have 5 of this quantity. Here I have 4 of nothing. So I cannot just combine those two because I have 4 near to 5. No, they are not similar quantity. I cannot combine them. So that's the idea. Here it's going to stay the same, and here will stay the same. You see, they are similar. I combine their value. They are not similar. I don't combine their value. For example, again, if I have 5x plus 7x, you see, those two quantities are similar. You see, I have 5 of that x and I have 7 of that x. So now those two are similar. What I do, I combine their value. So that means I will have 12x. The same idea. Even with the number, look, for that number, if I want to do it in terms of place value, what do I have? I have 200, 510, and 3 ones, plus 100, and 4 tens, and 1 ones. So if I want to add those two, I will combine the similar ones. That's why I'll have what? 300, 9 tens, and 4 ones. You see, the same concept. The same concept with this, we apply it in every type of addition we can have. So as they are similar, I combine their component. they're not similar, I just leave it like it is because they are not similar, so I cannot do nothing. I just write down the operation again. And the same thing with the metric measure. So suppose I have 4 meter plus 3 meter. You see, I have 4 meter, 3 meter. The units are the same. That means they are similar unit. So I add their value, or I combine their value. That's means I have 7 meter. Now if I have 2 meter and for example 10 decimeter, you see, I cannot combine those two because they don't have similar unit. But you see, the good thing about metric measure, we can convert. You see, that's the good thing. I can convert, for example, a meter to decimeter, or I can convert decimeter to meter. So that's the beauty of the metric system. So I can convert the unit to the other one. So here I can convert this to decimeter. So 10 meter is 20 decimeter and plus 10 decimeter. Now the units are the same, so I have 20 of the decimeter, I have 10 of the decimeter, so I can combine their value. So here is 30 decimeter. So I add the 1 with the 1s and the 10s with the 10s, and I keep the unit as it is because the unit always stays at the end. So this is another way when we apply the definition of addition. Another good thing about this definition is I don't need to know the component in order for me to add. I don't need to be familiar with the component. For example, so if I have, for example, 2 and this sign, and I have a number inside, for example, plus 5, I have this sign, a number inside. So here, so I don't need to know what is this. You say I have 2 of that component, or that component. I have 5 of that component. Those two are similar, so I can combine their value. That means the total here will be 7 of that thing. And if I have, for example, 3 of that thing plus 4 of that thing, you see, this and this are not similar, so I will not combine them. Do I need to know those? I don't need to know those. So what I need to know if their components are similar. I have 3 of this and I have 4 of this. The item, they're not similar, so I don't do nothing. So I just leave it like this, like was given to me the first time. So I can go even beyond that. So if I have 4 of this, for example, plus 3 of this, do I need to know what is this? I don't need to know what is this. I have an addition, 2 components. Are they similar? Yes, I have 4 of that thing, 3 of that thing. Those things are similar, so I can add their value. Do I need to know what is this? No, I don't need to know. If you know, it's better, but I'm just doing addition. So the definition is clear. Combine similar quantity. If they're similar, I combine them. If they're not similar, I leave them as it is. I will go with the last example. Suppose I want to add those two. So for example, I have 4 of this, x plus x2, 3x plus 5 plus 2x2 plus 4x plus for example 9. So here I want to add those two. So if I want to apply the concept of addition states combine similar quantity. So that's mean the first thing when I have this type of question or this type of addition I want to do, I'm going to look where are the similar quantities. So this and this are similar, so I combine them. This and this are similar, I combine them. And this, because they are the ones and they are just numbers, I combine them. So here I will have 4 of that thing plus 2 of that thing, so it's going to be 6 of that thing. So when the quantity are similar, I combine their value. So I have 4, the value of this quantity is 4, the value of this quantity is 2, so I will combine their value. This quantity has 3 as the value, 3 of that thing. Here I have value 4, so I combine the value here. Here I have 5, 9, so it's going to be 14. You see? And this, even a second grade third grade can do it if he apply the idea of addition by combining similar quantity. Now, what about negative number? So let's talk about negative number, how we can add with negative number. So what do you think? Let me make it very, very simple. Is it negative similar to positive? What do you think? Is it negative similar to positive? I believe the answer is no, yes? No. So if they're not similar, that means we cannot add them. Very simple. So we cannot combine them. So, and is it negative similar to negative? And then believe you say yes. That means we can combine them. That means we can combine them. That means we can combine negative, but you cannot combine negative with a positive. So if I have minus, for example, if I choose an example here, so if I have minus 4 plus minus 3, both of them are negative, so I can combine them. So when we combine, so I have minus 4 minus 3, what I do, I combine 4 and 3, and we keep the sign. Remember, the result is always similar to the component. So if the component is negative, the result is going to be negative. If the component is positive, the result is going to be positive. But if I have, for example, minus 7 plus, for example, 9, so this is not a process of combining this. So this we will see it in the coming lesson. So when we talk about subtraction. So, but this for now, we'll leave it like as minus 7 plus 9. If it was given to you as a question like that, so it's going to be minus 7 plus 9 till we do subtraction, inshallah. So that's how we deal for this question for now. So if we wanna, like for example, give a definition which is involved the sign, so the definition is going to look like the same definition as the one we did before. So what we do is just like, it's like we copy and we paste the same definition. The only difference here, so the only difference between those two, I'm going to just add same sign similar, same sign similar quantities to a single same sign similar quantities. You see the differences stay the same. So addition is a process of combining same sign similar quantities, so the sum must be the same. There are similar quantities, that's the same type of the quantities, into a single same sign. That means the output, it becomes the same sign as the component called the sum. You see, definition is the same definition. You don't have to add those if you want. If you don't want to add those two, still definition works with negative. Similar quantities, that must be similar. So same type and same sign. But if you wanna make sure that it's clear with the sign, so we can keep those two, and eventually will work for either positive, negative, or any type of quantity you choose, as long as the quantity are similar quantities. Let's do some example. So suppose I want to add those two expressions. So for example, I have minus 4x2 plus 7x minus 5 plus minus 3x minus plus 2x minus 9, for example. So here I'm going to look for the similar quantities. So what I do here is 3x2 here. So here those two are similar, same sign, similar. So I can combine their value, and the value will be the same sign as the component. So that means the value will be negative. So it's going to be minus 7x2. Here we have 7x, 2x, both positive, so I can combine. So it's going to be 9x. So here you see that we don't have a plus sign, we have a minus. Always the minus in front of the number belongs to that number. The minus in front of the number always belongs to the number. That means this one is minus 5 and this one is minus 9. This is the same thing if I have plus minus 5, plus minus 9. It's the same idea. Always the sign in front of the number belongs to that number. Always it go where the number goes. So if I move the number, so the sign move with the number. So if I want to move this one to this position, so it's gonna move with its sign. So always the sign in front of the number belongs to that number. Wherever the number go, the sign go with it, because is the sign of that number. So here I will combine those two. So I will have minus 14, or you can put plus minus 14, is the same answer. So if I have, for example, minus 3, for example, here let me choose another number. So 7 plus 4, 11 plus minus 4, 7, and here minus 3, 11. Again, those two are similar, same sign, so I can combine them. So here in that case I will have minus 7, 7. Those two, you see, the type of quantity is the same, but the sign they're not the same. That means they're not similar. So what I'm going to do here, I'm going to leave it like this for now. So for now it's going to stay the same till we talk about subtraction. Then we will learn how to deal with that type of operation. So this is a simple example how we add with the sign number. So I hope it's clear. This is all about the lesson today, so I hope you understand the concept of addition, and as you see, it's something that very simple, and even though if you don't know the component of addition, you can add as long as the components are similar, and if we add same sign similar. So if you have any comment about the way I present or the way I teach, do so. It will help me a lot. And thank you for watching the video, and Assalamu alaikum.